In this lesson, we talked about the cross product. In the previous lesson, we talked about the dot product. As you know, in the case of dot product, the product of two vectors was a number. But in the cross product, the product of two vectors is a vector. So let me first let you know how it is defined, and then I'll let you know a method that you can easily memorize how it is the cross product can be obtained. First, let me define the cross product. So suppose that we have two vectors u, which consists of three coordinates, a1, a2, a3. And we have vector v consists of coordinates b1, b2, b3. So the cross product of these two, u cross v, is another vector. It has three coordinates. The first coordinate is a2b3 minus a3b2. The second coordinate is a3b1 minus a1b3. And the third coordinate is a1b2 minus a2b1. So that's how the cross product is defined. Or in the other notation, if I write u as, instead of this notation, if I write this as u as a1i plus a2j plus a3k and v as b1i, b2j, and b3k, then this u times u cross product v is going to be the first coordinate I, second coordinate j, and the third coordinate k. And first, second, and the third coordinates are, as you see here, a2b3 minus a3b2 is the first coordinate, a3b1 minus a1b3 is the second coordinate, and a1b2 minus a2b1 is the third coordinate. So as I mentioned earlier, there is an easier way to remember the cross product, and that's by using determinants. So in fact, this form is the determinant of a 3x3 matrix. The first row is consisting of I, j, k. The second row is vector u, which is a1, a2, a3. And the third vector, I'm sorry, this third row is vector v, which is b1, b2, b3. If you expand the determinant, you will get to this formula. Just as a reminder of the determinant, like just as a reminder on determinant, if we have a 2x2 matrix, the determinant, suppose I have, say, a1, a2, b1, b2. If I have this 2x2 matrix, as you know, the determinant of this is A1 B2 minus A2 B1. For a 3 by 3 matrix, that's how we get that. Suppose I have a 3 by 3 matrix, A1, A2, A3, the first row, B1, B2, B3, the second row, and C1, C2, C3 on the third row. The way that we define that is we expand using the first row. Look at the first row here, consisting of A1, A2, A3. A1 is multiplied by the determinant of the 2 by 2 matrix, resulting from removing this column and the row and the column. A1 is located on the first row and first column. Forget about that and look at the remaining 2 by 2 matrix and the determinant of that B2, B3, C2, C3. This is the first term of the expansion of the determinant. Then minus, I look at the second number on the first row, A2. So minus A2 times the determinant of a 2 by 2 matrix. A2 is located on the first row and the second column. Forget about these two, this row and this column. The rest, B1, B3, C1, C3. And finally, the last term is coming with plus A3. And for that, I'll forget about the first row that A3 is located on and the last column that A3 is located on. The remaining is a 2 by 2 matrix. I multiply by the determinant of that 2 by 2 matrix. Now I know how to deal with 2 by 2 matrices. So this is A1 times the determinant of this 2 by 2 matrix, B2 C3 minus B3 C2. The other one minus A2 is multiplied by a determinant of that 2 by 2 matrix, B1 C3 minus B3 C1. And A3 multiplied by the determinant of that matrix, B1 C2 minus B1 C1. So this was a very quick reminder how to compute the determinant of 2 by 2 and 3 by 3 matrices. So this was determinant. As I mentioned, for using memorizing the cross product, one good way is the first vector on the left will go to the second row, and the second vector on the left, I'm sorry, the second vector from the left, so one more time. So the first vector from the left goes to this row, and the next vector, which is the second vector from the left, goes to the last row. And the first row obviously consists of I, j, k, those three standard unit vectors. So when I expand that, I will get to the definition of U cross V. In the cross product, the order of the vectors is important. In the dot product, it didn't matter which vector was first. U dot V was the same as V dot U. But in the cross product, it matters. In fact, if I interchange U and V, so V cross U is negative of U cross V. So that will be a vector in the same size, parallel to the original vector, but in the opposite direction. So if I interchange U and V, I get a vector of the same size, parallel to the original vector, but only in the opposite direction. So let's see some examples for computing the cross product of two given vectors. First example, let U be 1, 1, 1, and vector V be 2, 1, 0. So I want to compute U cross V. Sometimes the final answer is requested in this way, so I need to find the free coordinates like that. And sometimes it will be asked to show the cross product in the other notation for the vector. So something times I plus something times j plus something times k. This is in fact part 1 of this example. In part 2, I'll do V times U. Okay, now I would suggest that you pause the video and try to find this cross product using that determinant, and then you can watch my solution. Okay, so U cross V, I can do this determinant and come up with the answer. So the first vector U goes here, 1, 1, 1. The second vector, 2, 1, 0. So when I expand over the first row, I will have something times I. So I is multiplied by a number, but we know that since I is a vector, that number is multiplied. That number is written before I. Then minus j times some number. Let me put j there, because that number comes before j, and plus k times that parentheses, but since that parentheses is a number, comes before k. So for I look at so forget about this row and this column, look at the determinant of these 2 by 2 matrix. 1 times 0 minus 1 times 1, which gives me negative 1. So 1 times 0 minus 1 times 1 gives me negative 1. For the next term, j, so minus something times j, that something is the determinant of a 2 by 2 matrix. So I forget about this row and this column. I will have this 2 by 2 matrix 1, 1, 2, 0. So 1 times 0 minus 1 times 2. 1 times 0 is 0. 1 times 2 is negative 2. So that's going to be negative 2. Finally, for the k, forget about the first row and the third column. Look at this 2 by 2 matrix. 1 times 1 minus 1 times 2, which is negative 1. So the final answer is going to be minus I, negative, negative, positive, positive 2j, and minus k. So if I want to respond in the first format, here minus 1 goes to this spot, 2 goes there, and minus 1 here. So in that format, we don't use ijk. In the second way, the second form of showing the result, a minus 1i, so minus 1 here, 2j, and minus 1k. So I want to do v cross u. I know that in the previous page, in the previous slide, I mentioned that v cross u is negative of u cross v. It makes our job easier, but let's do it by this determinant and see that we really get negative of this result. I mean, the negative of the result of part 1. So in part 2 of this example, I'm going to do v cross u. And I do both notations, this notation and v cross u in the notation of I, j, and k. So I encourage you to do the determinant, the corresponding determinants, and see what you get. Okay, in this case, we have I, j, k on the first row. On the second row, vector v goes there. What was v? V was 2, 1, 0. 2, 1, 0. What is vector u? As you know, u was 1, 1, 1. So the same way that we did the determinant, if I expand over the first row, I times something, and that's something determinant. Since I is a vector, let me write I next, and then minus j times a 2 by 2 determinant, and since j is a vector, let me write j after that parentheses, and then plus a parenthesis k. For I ignore the first row and the first column. I have a 2 by 2, 1 times 1 minus 0 times 1 gives me just 1. Excuse me. For J, a similar situation. Forget about the first row and the second column. The remaining 2 by 2, 2 times 1 minus 0 times 1, it gives me 2. For the third parentheses, K is located on the first row and the third column. Ignore those two. 2 times 1 minus 1 times 2, which is 1. So the answer is I minus 2J plus K. If I want to fill in those blank spaces, for the first one, I means 1, I, so the coefficient is 1, or the first coordinate is 1. The second coordinate is minus 2 here, minus 2. And the third coordinate is 1K, so it is just 1. Or if I want to use the other notation, minus 2J and 1. And as you see, the answer is negative of part 1. In part 1, the answer was minus 1, the vector minus 1, 2, minus 1. Here I get 1 minus 2, 1. So this is consistent with that property that I mentioned before, that U cross V is negative of V cross U. Using the definition, you can try to find some simple cases, like, for example, suppose I want to find I cross J. If you do that, if you use that determinant and find I cross J, you will get that equal to, you can try on your own before you see the answer. You can pause the video. If you try that and simplify, you will get K. Or if you do J times I, you will get negative K. Like for the first one, if I go with the definition, I is what? I is 1, 0, 0. J is what? 0, 1, 0. So I cross J, I can use the determinants, I, J, K. Then I goes to this row, 1, 0, 0. J goes to the next row, 0, 1, 0. If you do this determinant and simplify, at the end, you will get just K. For J times I, you should write the coordinates of J on the second row and coordinates of I on the third row. You will get a negative K at the end. You can also do the same thing for like J and K. J times K is going to be equal to I, but K times, I say time, but I mean cross. K cross J equals negative I. In a similar manner, K cross I is J, but I cross K is negative J. One interesting thing in this regard is I cross itself is going to be the 0 vector. It will be 0, 0, 0. J cross J is also the zero vector, 0, 0, 0. And K cross K is also 0, 0, 0.